Our next unit of study in geometry is going to be relationships within triangles. And to begin this, we're going to be talking about midsegments of triangles. So to begin with, what exactly is a midsegment? Well, quite simply, when you have a triangle, a midsegment is a line that connects the midpoints of two of the sides. So we're going to be looking at the relationships that come in a triangle when we have these midsegments. And to begin this, we'll look at a theorem, which we'll call Theorem 5.1, which is midsegments of triangles. And for that, if a segment joins the midpoints of two of the sides of a triangle, then is parallel to the third side and half as long as well. So in the diagram that was drawn previously, this segment here is parallel to this line segment, and it is also half as long. So if I were to draw a midpoint mark there, the claim is that this segment is congruent to either half of the base of this triangle. So we can use these relationships in order to get parallel sides, and with parallel sides all of our parallel theorems, and also to find missing pieces from those parallel theorems. So let's take a look at how we can do that. In this triangle, large triangle ABC, we have midsegments MN, MO, and NO. So we have constructed a series of midpoint segments. So we have all these congruent segments that result from it. Our first task here is to identify parallel line segments. And as we go, we will mark them on the diagram. So I know that AC is parallel to the line segment constructed from the other two, which is MN. I also know that AB will be parallel to the segment connecting the opposite of the other two sides, which would be MO. And last, BC is going to be parallel to NO, because those are the sets, NO, BC, that are made of connecting the sides that are not the one we're talking about. So we have parallel lines showing up here and here, here and here, and last three lines here, or 3 arrows here and 3 arrows here. So with our parallel lines, we have one extra fact that we're going to take a look at now, and that is quite simply if the measure of angle A is 50 degrees, what other angles would we be able to tell from this information? So here at angle A, I have 50 degrees. While using parallel lines and corresponding locations, I would know that the measure, let's get a color that will show up a little bit better. So the measure of angle BNM, which is this angle right here, will also be 50 degrees, because those are corresponding angle, that's a corresponding angle to angle A. Next, the measure of angle MOC will equal 50 degrees, because again it's corresponding off a different set of parallel lines to angle A. Another thing we can do is, if we're giving measurements of some of our side lengths, we'd be able to find missing parts of the triangle due to the congruence of midsegments. So in this diagram, DE is a midsegment connecting AC and BC, and EF is a midsegment connecting CB and AB. We know that AD is 6 units and DE is 7.5. We need to find the measurements of DC, AC, EF, and AB. So let's take a look at them one at a time. Line segment DC. Well, line segment DC is the other half formed from midsegment DE. So if AD is 6, then DC would have to be 6 as well. Next, let's look for AC. Well, AC is this entire side, so if we know that the pieces are each 6, then we can come over here and say that AC, remember without the line segment marker on top, it means the measurement of, would equal 12. Next, we need EF. Well, EF is located here. It's the midsegment connecting BC and AB, which means that it is parallel to AC, and according to our theorem, it is also half the length of AC. So, EF would have to be 6 as well, because it is half of AC, is congruent to each of the bisected pieces, AD or DC. Last, let's look for AB. Well, AB is here, and we know that we have midsegment DE, which is parallel to it, so DE is half the length of AB. That means each part of AB, so that's AF, will be the same size as DE, so 7.5, and FB will also be that same measurement at 7.5. So that means AB in total is going to be 15, the sum of those two put together. Now, without having any information about midsegment DF, that's as far as we can go. But you can see with midsegments in this theorem, Theorem 5.1, we're able to develop a lot more information and material from a simple sketch or drawing. So look over this information, make sure you have it down and ready to move forward with it, because we're going to be using it here in our study of the relationships within triangles.